In this lecture, we will see in detail about the creation and annihilation operators for harmonic oscillator problem. Why that harmonic oscillator problem is important? The Hamiltonian operator for harmonic oscillator is p cat squared over 2m plus half k x cat squared. Which here you can see uh, 2m is a constant, 1 over 2m is a constant, so it is p squared. Kinetic energy is proportional to p squared and potential energy is proportional to x squared. So there is a symmetry between kinetic energy and potential energy. Unlike in the case of infinite square well potential, here it is a symmetrical one. That is one major advantage. Then why we have to study, we will see this. Then this k can be written as m omega squared. So uh, the Hamiltonian is p squared over 2m plus 1 over 2 m omega squared x cat squared. Uh, and also here you can see the nth state energy of the harmonic oscillator is n plus half times h cross omega. Here I would like to highlight three important points. One is when n equal to 0, it is half h cross omega. So this is called 0 point energy. So there will be a minimum energy of half h cross omega. uh, then the energy is quantized. N is an integer, so it is it is it varies as a h cross omega by an integer of h cross omega. So energy is quantized, it's not a discrete one, and the energy difference between two consecutive states is h cross omega. So is the if n is equal to 1, the energy level is 1.5 times h cross omega. If it is 2, then 2.5 times h cross omega. So difference is h cross omega. If you take any two consecutive state, the energy difference is h cross omega. That is another important point. So the Hamiltonian operator for harmonic oscillator is p cat squared over 2m plus half m omega squared x cat squared. Now you know that x squared plus p squared can be written as x plus ip into x minus ip. Why we are putting in the imaginary part for momentum is the momentum operator is equal to minus I h cross delta over delta x. So there is a logic in it. So same formula we will use. We will create a annihilation and creation operator based on the position and momentum operator. Here you can see the annihilation operator is x divided by square root of 2h cross over m omega squared. See here this denominator, this dimension of this denominator is x. So first term there is no dimension, and similarly here this denominator has a dimension of momentum. So this is a dimension. I will differentiate. This is dimension of momentum. This is dimension of x. So both dimension will get cancelled. So it is a annihilation operator is a dimensionless quantity. I have discussed so many times the advantage of having dimensionless quantity. You can even use the power series of that. Whereas if it is a dimensional one, you cannot do it. Moreover, instead of using position and momentum operator, you can use annihilation and creation operator, which in which you can produce the result in a easier manner, that we are going to see by the way of solving the problem. So this first term can be written as square root of m omega over 2h cross x plus this term I am taking as it is I p cat over square root of 2m h cross omega. Here, by definition, this is equal to annihilation operator. For creation operator, just a complex conjugate of this. That is, this will become minus. Here it is plus, this is minus. This A dagger is a creation operator. Now we will convert the Hamiltonian operators in terms of creation and annihilation operators. So we know the just now we have seen creation operator is this one and annihilation operator is this one. Just minus change to plus for annihilation operator. If you take A dagger A, you multiply this with this. So first, I have written the X operator in green color bond and P operator in the violet color. So now first multiply this one first term here first term. This will become m omega over 2h cross x in here one x cat square. Similarly, you multiply this violet color, these two terms. So this will become I squared. I squared is minus 1. Here already there is minus. So this will become p cat squared over square root of 2m h cross will become. You are multiplying square root of 2m h cross with the square root of 2m h cross, which will become 2m h cross omega. Now you multiply the cross term, that is x and p. So you are not supposed to change the operator, that you know very well. So if you multiply this first term and second term, this will become xp. There is one I here, and m omega, square root of m omega in the numerator will get cancelled with the square root of m omega in the denominator. And in the denominator, you have additionally 2h cross and 2h cross, square root of 2h cross. So, which will become 2h cross. Similarly, now you multiply this p and this x. Then here you have minus ip x, and same thing. That is, you are uh, multiplying this and this. So this square root of m omega will get cancelled like this, what we have done. So in the denominator, you will have 2h cross. So first two term you keep as it is. Third term, this can be written as 1 over, sorry, I over 2h cross xp minus px. Xp minus px is the commutation of x with p. So this can be simplified as I am taking the I constant outside, I over 2h cross, then this is commutation of x with p. You know the commutation of x with p is equal to I h cross. So here this h cross will get cancelled. This I into I will become I squared, that is minus 1. So this will be minus half. So A dagger A is equal to P squared over 2 m h cross plus m omega over 2 h cross x cat square minus half. We will further simplify this. So we have seen that A dagger A is equal to P squared over 2m h cross omega plus m omega over 2h cross x cat squared minus half. You bring this minus half to the left hand side, then it will become plus half. You multiply this by h cross omega both right hand side and left hand side. Then in the left hand side, I have multiplied this by h cross omega. Here in the right hand side, first term, if you multiply with the h cross omega, this will cancel out with the h cross omega in the denominator. So this will simply become p cat squared over 2m. Here, if you multiply the second term by h cross omega, this h cross will get cancelled and omega will become omega squared. That is m omega squared x squared. This is exactly what we defined the Hamiltonian operator in terms of position and momentum operator. So which is equal to this h cross omega A dagger A plus of, that is in terms of annihilation and creation operator. So Hamiltonian in terms of annihilation creation operator is equal to H cross omega multiplied by A dagger A plus of, which is exactly equal to the position and momentum operator. That is the beauty of this expression. Then here this number operator, this number operator, A dagger A is called a number operator. We are going to prove the reason why it is called a number operator in later section of this lecture. So this is equal to n. So the Hamiltonian for the harmonic oscillator in terms of creation and annihilation operator is H cross omega n plus of. We will see further detail. We have seen that the Hamiltonian operator for harmonic oscillator using annihilation creation operator is H cross omega n plus of. Uh, when this Hamiltonian acton get n, that is H cross omega, this acton get n plus of will acton. Of is a constant, n is an operator, number operator. So when capital N act on the get n, it will gives you the eigenvalue n, which I have designated as small n. So this will gives the eigenvalue of n plus of. So which is equal to nth energy state, which is exactly same as that one where we obtained using the position and momentum operator. Then the number operator. What about the number operator? Whether it is Hermitian or not? N is equal to, by definition, is equal to A dagger A. So N dagger is the whole thing. We are taking complex conjugate. When you are taking complex conjugate, this order will get reversed. So A comes first, A dagger comes next. So A of A dagger is A dagger. Then A dagger of dagger is A. So A dagger A you are getting. So that is equal to N. So surely that number operator is a Hermitian operator. Here I have just mentioned A dagger, annihilation and creation operator. I have informed that square root of m h cross omega is momentum dimension, having dimension of momentum. Similarly, m omega over h cross is having inverse of dimension of position. Then you may ask the question, why these two here? This is for mathematical reason. You know that the Hamiltonian for harmonic oscillator in terms of position and momentum operator is p squared over 2m plus of kx squared. So in both kinetic energy term, potential energy term, you are getting off. That is the reason. Even without these two, you will get same result. After all, this is a scaling factor, so don't worry about it. Now we have seen that cat, that is annihilation operator is square root of m omega over 2h cross x cat plus I p cat to square root of 2m h cross omega. Now what I am going to do is this, you keep as capital X, this thing as capital X cat. Remember that this capital X cat is X cat is a dimensionless quantity. Similarly, you keep this other than I, this one, as capital P. So sorry, other than I, it is capital P. Uh, so this is a capital P is other than I. So P cat is capital P cat is dimensionless quantity. Same thing is here. Same thing applies here. This is a dimensionless quantity, capital P cat, and this is entire thing is X cat. This is X cat. So now A cat is equal to x plus IP cat. Both are capital. A dagger is x capital X cat minus I P cat. So now you take the commutation between the capital X cat and capital P cat, which is equal to capital X cat is square root of m omega over 2h cross X cat, and P capital P cat is equal to P cat small p cat over square root of 2m h cross omega. Now you take this constant, that is here you take m omega 2 h cross outside the commutator, and this denominator outside the commutator. So uh, then if you I have taken that square root of m omega over 2 h cross and 1 over square root of 2 m h cross omega. Now here you can see square root of m omega will cancel with square root of this m omega. Here you have m and omega. Then in the denominator you have square root of 2h cross square root of 2h cross, which will become 1 over 2h cross. Now here you have x and p. So commutation of x with p is equal to I h cross. That's what I have written here. Here, this H cross will cancel out. Then you will get left with in the numerator it is I, in the denominator it is 2. It is interesting to note that the computation of this capital X and capital P is I over 2. This is a dimensionless quantity naturally, because X and P are dimensionless quantity, where small x commutation between small x and small p is equal to I h cross. Here h cross is having dimension. So it is a very important conclusion that commutation of capital X cat with capital P is equal to I over 2. This we are going to use in my lecture. Now we will see the commutation relations of annihilation and creation operator. First, you take A dagger. By definition, A is this one, first one, x plus IP, and A dagger is x minus IP, both capital. So now you can expand this commutator. X and X commute, so don't worry about it. But X and minus IP will not commute. So here you take minus I X X with commutation of X with P, because X with X will commute. Similarly, P with P will commute. So that you can ignore. So P and X will not commute. So here you can take I outside. P commutation of P with X. Now, what is the commutation of X and P, X with P, capital X with P? Now only we have seen this is I over 2. What about this? The order changed. Here XP, PX. Naturally, this will be minus I over 2. So here you have already minus I over 2. Here you have plus I and minus I over 2. So I into I square minus 1. Minus of minus is plus 1. Same thing is here. Here also plus 1. So 1 by 2 plus 1 by 2. Half plus half is equal to 1. So A dagger with A is equal to commutation of A with A dagger is 1. This is very important equation, which we are going to use in future lecture. Not only in future lecture, we are going to use this to solve the problem related to harmonic oscillator. Now we will see the some more relation about the commutation relation. Commutation of n number operator with a dagger is equal to the reason I said I will explain at the end of my lecture. Why it is called number operator? So number operator is A dagger A, commit with A dagger. Using commutator expansion, this right hand side, left hand side A dagger will become left hand side. Then this will be A dagger. Similarly, this right hand side A will become right hand side. Then this will be a dagger with this A dagger. The commutation of A dagger with A dagger is 0. You know very well it is 0. So this can be cancelled. Then naturally only A dagger, A dagger. A dagger, you know, just now we have seen A dagger is equal to 1. So naturally, this will become simply A dagger. So the commutation of number operator with A dagger, you will get A dagger. So number operator, it raises the energy by one unit, that is H cross omega. So here it is A dagger. A dagger is a number creation operator. So you will get. In similar way, what will happen to a computation of number operator with annihilation operator? So number operator is A dagger A with A dagger. Here you expand the commutator relation. So this right hand A dagger, left hand A dagger will become left hand side. Then this is A dagger A. Then next, this left hand, right hand side will become right hand side. A cat. Then this will be A dagger A dagger A. So the first term A will cancel with A and A commute. This will be 0. So naturally A dagger is 1. Naturally A dagger A is minus 1 because its order is changed. So you will get minus A dagger. This is the annihilation operators. So you got the minus here. We will further develop this one. So now we will see about the creation operator and annihilation operator. What will happen if number operator act on and the get n? See, for that we are going to use the commutation relation. Uh, that is commutation of n with a dagger is equal to a dagger. Just now we have seen. Just to expand this, which is equal to a dagger minus a dagger n. Sorry, n a dagger minus a dagger n, which is equal to a dagger. Now you bring this to right hand side without changing the order of the operator. So this will become plus. So this will become a dagger n plus a dagger. So a dagger I am taking as common. So n, this will become n plus 1. So this is equal to a dagger n plus a dagger. So I got this. What will happen if n operate on get n? So let us say if n act on get n, it produces the eigenvalue of n and with get n. Now you use this relation n a dagger n. Uh, that is n is the eigenget of number operator. Naturally, a dagger n also eigenget of number operator. That is basic postulate in quantum mechanics. Now n a dagger you have taken. In the right hand side, you take this one. A dagger n plus 1. So when n number operator act on get n, it produces the eigenvalue small n plus 1. This is a number I am taking front. So a dagger I am keeping out. Here you can see a dagger and here a dagger n. So when creation operator act on n, get n, it gives the eigenvalue of n plus 1. So a dagger n, remember that this is get n will become get n plus 1. Same thing is for annihilation operator. You do the similar thing here. You take the commutation of n with a annihilation operator, which we have seen just now is minus a. So if you expand this, you will get Na minus An. Now you do the same thing. You bring this minus An to the left hand side. Sorry, right hand side. This will become plus an minus a. So if you take a as a common, then this will become n minus 1. So Na is equal to a multiplied by n minus 1. If n operates on get n, what will happen? When n act on get n, it gives eigenvalue n multiplied by this get n. What we have done here. Now the left hand side you use this relation n a get n. See, since n is a eigenget of number operator, a n also eigenget of number operator. You take this right hand side here. Right hand side. This is a n minus 1 get n because n a, this n a is equal to, according to this relation, a n minus 1. When n act on the get n, you will get the eigenvalue small n. So this n minus 1 number you can take out, you bring this a here in the after this number n minus 1. So you got an here, an here. Now when an act on the get n, it reduces the energy state by 1, that is n minus 1. N reduces to n minus 1. Similarly, here you can see when creation operator act on n, it increases its energy state by 1, that is n plus 1. Now we will see the expansion coefficient of a creation operator. When a dagger act on n, that is creation operator act on n, you will get n plus 1. That is get n plus 1, you will get n plus 1 when creation operator act on get n. With the expansion coefficients Cn. Now our aim is we have to find what is expansion coefficient Cn. Now you take a inner product with n plus 1. So this will become n plus 1 into n plus 1. Draw n plus 1 and get n plus 1. This will become Cn squared bra n a, because this is the Hermitian operator. Sorry, a dagger individually not a Hermitian operator. That you have to keep it in your mind. So this is complex conjugate of this one. So a dagger a is a dagger a is not a number operator, that you have to keep it in your mind. So I want to change this. You know, a dagger is 1. Computation of a dagger is 1. That is a dagger minus a dagger a is equal to 1. Then a dagger is equal to this, you bring the other side, which is equal to a dagger a plus 1. Here a dagger a is n number operator, so n plus 1. So this a dagger is n plus 1. So again I want to repeat, a and a dagger are not a Hermitian operator, that you have to remember. But number operator a dagger is number operator. Sorry, a dagger a is a Hermitian operator. It's combination. So this will be n plus 1. So I am using n into n plus 1. Try n plus 1, get n plus 1. Here, you know, this is equal to 1. This is 1. Inner product is 1. So I have taken this to the right hand side. Then I have kept this in the left hand side. That is modulus Cn squared. Um try n plus 1 get n. When n act on the get n, it will produce the uh, eigenvalue n, small n. So you can take, this is a number you can take out, n plus 1, and cn modulus cn square, and here pra n get n. That is inner product of n with n is equal to 1. That means Cn square modulus Cn squared is into n plus 1 is equal to 1. That means Cn is equal to 1 over square root of n plus 1. So here you take the first equation and get n plus 1 is equal to Cn a dagger n. Cn is, we have seen just now, 1 over square root of n plus 1 a dagger n. Now you bring this denominator to the right hand side. So this a dagger n is equal to this square root of n plus 1 into n plus 1. So when a dagger act on the get n, you will get square root of n plus 1, that is expansion coefficient, with the get vector n plus 1. Remember that here it is square root of n plus 1. There is an important point I will explain. When n is equal to 0, that is ground state, then it will go to the next state, that is 0 plus 1, first state. So then if n is equal to 1, it will go to next higher state, the square root of 2. That I will come to it within 2 minutes. Now we will find the coefficient of annihilation operator. You will get n minus 1, get n minus 1 when the annihilation operator act on get n. Of course, with the expansion coefficient Cn. So now you take inner product as usual, what you have done for creation operator. So this will be n minus 1 with n minus 1. Try n minus 1, get n minus 1. Then you take n, a get n. If you take inner product, this is pra a. This will get complex conjugate. That is a dagger. So this Cn will become modulus Cn square. Now this inner product is 1. You know, this is very well known. Inner product is 1. So I have brought this to the right hand side. Now modulus Cn squared n, capital N act on the get n. So when capital N act on get n, it gives the eigenvalue small n. So an eigenvalue is a number you can take out. Then you will get n plus, that is inner product of n with n, which is equal to 1. This is 1. So naturally, modulus Cn squared n is equal to 1. Then naturally Cn is equal to 1 over square root of n. So here you take this expression and get n minus 1 is equal to Cn a get n. So Cn I have replaced 1 over square root of n, 1 over square root of n. So you bring to the right hand side. This will be square root of n into get n minus 1. That is a get n is equal to square root of n get n minus 1. Previously for creation operator, we have seen square root of n plus 1. Here it is not n minus 1. That is very, very crucial point. So if it is n minus 1, what will happen? We have not made any assumption. We got it as it is. So if it is n minus 1, when n is equal to 0, you will get square root of minus 1, which is not allowed one. So when n is equal to 0, this will become 0. You cannot bring the energy state below the ground state energy. Whereas here when n is equal to 0, ground state energy, the system will move to next higher energy, that is 1. So if it is 1, it will go to 2. That is the very important point. A dagger is equal to square root of n plus 1, whereas A is just square root of n. That is a very interesting property. Here coefficient is root n, here it is root n plus 1. Now we will go further. Uh, Now we will see very interesting phenomena, that creation operator matrix. So when bra n plus 1 act on a dagger n, this is creation operator traces the get n to n plus 1. So the inner product will be 1 1 x. But all other cases it will be 0. Only the bra get vector are same, you will get 1, otherwise 0. So now when a dagger act on n, just now we have seen, it is equal to square root of n plus 1 get n plus 1. So square root of n plus 1, you can take out the n plus 1 into bra n plus 1 and get n plus 1 will become 1. So you will get only the coefficient square root of n plus 1. Now I will come to the very important point. See, this bra vector is a column vector, zeroth column, first column, second column, third column. It will go like this. Similarly, the get vector, by definition, get vector is a row vector. So this is row, zeroth row, first row, second row, third row, and it will go like this. So now you take n equal to 0. What will happen? N is equal to 0 means bra vector is n plus 0 plus 1, 1, first one. Then this is n equal to 0 here. So zeroth column. So this will be 1. How it is 1? You know that n is equal to 0, this coefficient. 0 plus 1 is 1. Square root of 1 is 1. Similarly, when n equal to 1, here n equal to 1, then this is second row. So this is second row, and n equal to 1, first column. Bra vector is, get vector is 1, first column. So it will be 1 plus 1 square root of 2. So it will go on like this. So this will be 3. That is second column and third row. Because when n equal to 2, this is 2 plus 1, 3. Third row, uh, 2 is second column. Square root of 3, it will go. So you will get octagonal element 1 square root of 2 square root of 3 square root of 4, 5, 6 and all. Then if it is n plus 1, what will happen? It will go, that is, I will use different color. It will go octagonal element. This second row. This is octagonal element. When bra vector is n plus 2. Similarly, if bra vector is n plus 3, then it will go like this. Square root 1, 2, 3. It will go. This is n plus 3. So this is about the uh, creation operator matrix. Now we will see the annihilation operator matrix. Now we will see the annihilation operator matrix. This is very, very interesting one. See, when n minus 1, bra vector n minus 1, uh, if you take inner product of A, that is annihilation operator A act on get n, it will produce n minus 1. So it will be inner product will be 1. So, however, here n cannot be 0. N 0 means this is minus 1. So not only that, when n is equal to 0, when a act on n, you will get expansion coefficient square root of n, which I have already explained, multiplied by get n minus 1. When n is equal to 0, Square root of 0 is 0. So this is null vector. So you cannot get anything. So this is as usual, zeroth column, first column, second column, and third column. Similarly, this is zeroth row, first row, second row, like previous case, third row. Now n cannot be 0. When n is equal to 1, what will happen? N is equal to 1, so 1 minus 1, 0. This is row vector, 0th row. Then here n is 1, 0, first column. So first column. So n is equal to 1, 0th row, first column. That is square root of n is 1, square root of 1 is 1. So we will get. Then when n equal to 2, 2 minus 1, 1. That is row vector is 1. What about the column vector? Column vector is 2. So second column. So this is square root 2. Column vector is 2. N is 2. So square root of 2. So this will go like this as previous case. This is upper of diagonal matrix. So when is n minus 2, as I said previously, this will go along this line. If n is equal to 3, it will go like this. So for annihilation operator, you will have upper of diagonal matrix. For creation operator, it is lower of diagonal matrix. So that is very, very interesting. Now we will see the number operator matrix. That is pra n, a dagger a is number operator, get n, which can be replaced as n number operator, act on get n, will gives you the eigenvalue of n. Then naturally, this n inner product of n with n is 1. So from this you can understand row vector and column vector are same. So naturally this is the diagonal element. So when n is equal to 0, this is 0, n is equal to 1, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. So you will get a diagonal element only. So what is after all the diagonal element means is an eigenvalue. Diagonal elements are eigenvalue. Eigenvalue varies from 0, 1, 2, 3, 4, 5, 6 up to n. Here, that is one point. You can use this relation n, the inner product of n with n. So that is the diagonal matrix. Even otherwise, you can multiply a dagger with a. So first row, this row, zeroth row, zeroth column, you will get 0. Zeroth row, first column, you will get 0. So first row, all thing will become 0 because you are here all the element in the rows are 0. Here you can see the first element alone 1. So all others are 0. So if you take this row and all column, first column 0, second column 1 into 1, 1. Then third column, the second element only square root of 2. You are multiplying with this. Only first element is multiplied by 1, all others are 0. So only 1 will come. If you take 3, third one, here third one only because all other columns are 0. So square root of 2, square root of 2 will become 2. If similarly, square root of 3, square root of 3 will become 3. So, a dagger a exactly gives this. So, you need not to multiply a dagger a. Just from this, you can conclude this relation. So, now you understand why a dagger a is called number operator. It gives the number which is nothing but your eigenvalue. Thank you very much for watching my video and supporting me continuously. Thank you very much.